Welcome to Lesson 2 in the series of lessons supporting the textbook How to Program Effectively in Delphi for AS A-Level Computer Science. This lesson is an introduction to object-oriented programming in Delphi. We will start with a console mode program and then a console mode program that creates a GUI and then finally a GUI. Let's get started. We will start with a console mode program. So we go File, New, Console Application. We will delete the try except end template because we don't need it for this very simple example. We will save the project. In a new folder, Console Form 1. And we'll give the project the name Console Form. And note the program name now changes from Project 2 to Console Form. We need a type definition of a class, so we use the class template class F, press Ctrl J to complete the template, and we get tMyClass with field specifiers private, protected, public, published. We don't need tComponent, so we will delete that. We don't need the protected or the published. We change the class name to tPerson. And we're going to indent to the house style that I prefer, which lines up class and end, the C of class with the E of end, indenting private and public 2 columns, and we indent the type definition 2 columns. I haven't lined up the C of class and the E of end. I'll do that in a moment. We need a variable of the type tPerson that we will use to reference an object of type tPerson that we are going to create. An object reference is just simply a memory address. tPerson supports several methods, and we're going to use a special method that belongs to tPerson. If we do Control Spacebar, we'll see that the tPerson type is already there in the pop-up menu. If we do then tPerson full stop, we can see all the methods supported by the tPerson class, and the one we're going to use is a special one called a constructor, and it has the name create. And what create does is grab sufficient memory to store the state of the object, and person1 will store the address of this memory space. We're going to use WriteLine to write out the state of the object, but at the moment we're not recording anything because we don't have any fields. So we're going to add a field name of type string, and then we'll have a receptacle to store a string, and it will be referenced by the identifier name. So we use the dot notation again to add name reference, and now we need to assign a value to this object, to the name field, So again, we reference the object and then the name field, person1.name is the way we do this. And then we read a value from the keyboard and we copy it to the object in memory and store it in the name field. And we'll add a prompt so the user knows what the program expects to be typed at the keyboard. And we need to stop the console window closing, so we add a read line, so we need to enter to close the console window. Oh, that's an untidy prompt. We may need to make it look a little bit better, so we'll add a colon followed by a space, and this is our first object-oriented program. We enter the value Fred blogs, I misspelled Fred, never mind, and that's going to be stored in the object space in memory, and that will represent the current state of the object. Current state of the object is it has a value Fred blog stored in its name field. Now, as I said, the class tPerson supports some methods already, and we want to use the instance size method to find out how much memory has been allocated to this object of type tPerson. We call it an instance of the object tPerson, of the class tPerson, beg your pardon, tPerson instance. So we enter a value for the name field. Program outputs the name value to the screen, and the instance size is measured in bytes, so the object actually occupies 12 bytes of memory. Can we increase the amount of memory by adding another field? Yes, of course we can. So if we extend the class definition with another string field called nickname, run again. And how big is the instance of this class? Well, it's 16 bytes now, so it's increased by 4 bytes. And we'll add another string field, and we'll see what the instance size is. And this time I use the expression object instance has size 20 bytes. That suggests, with 3 string fields and each one adding 4 bytes, that what is actually stored in the object is a pointer to a string. A pointer being a memory address which has the size 4 bytes. Let's add another object reference person2, and remember the reference is a memory address, person1, person2. Each will store the address in memory of the instance of the object. So we need to change the reference from person1 to person2, and we will have 2 objects occupying 2 spaces in memory, and we'll be able to update the state of the object. First one will update it to Fred Blogs, and the second one to Mary Smith. And both objects require 12 bytes of memory, plus the memory to store the characters of each string. And that's our first object-oriented program. Where do the methods such as instance size come from? Well, tPerson has ready access to a set of methods that are actually defined in a class called TObject, and every class which is created by the user in Delphi will actually extend that class TObject. We could have put TObject in brackets after the keyword class, but if it's omitted, it is assumed that this class defined by the user is actually extending TObject. Next up, creating our own methods for dealing with an object's state. For this, we're going to create a method setName in the public section of the class definition. We're going to use the keyword procedure because the method setName is just going to carry out some instructions, and we're going to add a method which will return the state of the name, and we use a function keyword for this, like a mathematical function. You put something in, you get something out. Now notice that setName and getName are underlined in red because it's an error message saying that both are unidentified forward or external declarations. So we actually need to define what the instructions are for setName and what getName is going to return. So we use Control-Shift-C to create the skeleton for the function getName and the skeleton for the procedure setName. I'm just going to tidy up by indenting according to house style. I use Control-D for this, and then I'm going to use Control-Shift-I to indent the block. It doesn't always work as well as one would wish, and I want to line up the E of N with the C of class. And I don't think I've quite done it, but I'm not going to bother at this stage. Now Control-Shift up arrow and Control-Shift down arrow will take us between the method declaration and its actual implementation. Okay, I'm just going to copy the code from the main block that we use to set the name, and I'm going to paste it into the procedure setName, or the method tperson.setName. Now, we don't have any objects at this stage, so we can't be specific. We can't use person name, so we're going to use the identifier self, which is known to the system, and self will always refer to the object which is being referenced. So the address of the actual object will be substituted for self so that we can access the state of the object's name field. Now to return a result, we just say result becomes equal to, and again we use the self reference to the object and to the state of its name field. So now we're going to skip in a moment directly accessing the name field, and with the code completion we're going to use the method setName to set its name, and we're going to use the method getName to copy the state of the name field. So now we've referred to the state of the object indirectly via two methods that we can use when we have an object by referencing the object and saying I want to use the method setName, or I want to use the method getName to get the state of the object's name field. And we'll do the same for person too. So self is a hidden variable, but you don't really need to know this at this stage, which always refers to the current object, and it actually accesses the address in memory of the current object, so you can manipulate its state. Sometimes you don't need to explicitly use the keyword self, because it can be implied depending on the context in which the object is being used. Okay, I've quickly added two comment symbols. All I did was press Ctrl J on the keyboard when the cursor was on the particular line I want to comment at, and now the compiler will not compile these two right line statements. They will be absent from the running program, and so we won't get instance size outputted to the console window. So we've got two object methods, because in order to use them, they are object methods. In order to use them, we need a reference to an object. Once we have a reference to an object, then we can use them. If we don't have a reference, we can't use them. So they are actually object methods, but they're declared in the class. Now that is different from, for example, the constructor method, create, which we can use without having an object to refer to. Now, we can always use Control space if we can't remember the name of the variable or the identifier, and we can use code completion, full stop. Now, at this stage, we're about to exit the program, but we've still got a couple of blocks of memory allocated to two objects. So we need to deallocate that memory, and we do that with the free method, which is an object method that tPerson inherits from TObject. Okay, we're now using the methods to obtain Fred Bloggs and Mary Smith and allocate them to the name fields of each object. Okay, can we still access the name field directly? Let's see. So Control space will bring up information about all the identifiers belonging to or accessible to the program. So we've outputted Fred Bloggs using getName method, and we've also outputted it directly going to the name field of the object belonging to person 1. So why have a method getName when we can access the name field of the object directly? Well, the problem is that we've got our type definition in the main program, and even though we're using the specifier private, make name private, it's not going to be private, because anything in that main program can access anything in that type definition. So what we need to do is we need to create a separate unit. So we do File, New, Unit, and then we need to copy the type definition to this new unit. We need to remove it from the main program, but we still need to reference it in the main program, so we need to put it in the interface section. And we need to copy the implementation of these two methods, but we're going to hide their implementation from the main program by putting their implementation in the implementation section. Makes sense, doesn't it? Implementation in the implementation section. Now this section will not be visible outside of this unit. Now the type definition is visible except for any fields or methods which are defined in the private section of the class definition. So here we are going to be able to enforce privacy because the name string is declared in the private section of the class, and because the class definition is in a separate unit, it's not going to be visible outside of the class. How does the main program access the unit? Well, there's a reference there. It says the program references unit 1 in unit1.pas. And now you can see cannot access private symbol. So writeline person1.name is not compilable. So Control J just to comment it out for the moment. So the name field of the person1 is not visible in the main program any longer. And this is a good thing because now we can control access to the state of the object in the way that we define. So let's create a third object, and we're using a class method create, not an object method but a class method create. We don't need an object reference. In fact, what we use is a class reference, tPerson, to access a method that belongs to the class. And now person3.setName, we're accessing an object method that belongs to an object of type tPerson. And of course we need to free up the memory space or deallocate it at the end of the program. In fact, the program will tidy up, but it's always good practice to explicitly deallocate the memory. And the state of the third object is being updated. Its name field is now being set to Mike Brown. And we'll just tidy up the program, compact it down. The free method deallocates the memory, but it doesn't remove the address that the memory used by the object. And so you've got to be careful not to use that address. For instance, if you did person1.setName again, you'll get a runtime error. There is a procedure called free and nil that takes as an argument person1, for example, the object reference, and it will set it to nil. But you can set the person or the object reference to nil yourself. But do take care. Next up, Lesson 3, creating a GUI from a console application. Thank you for listening.